talk about significant figures. Significant figures is going to be a major part of this course, so it's really important that we get this in the beginning and so that we can use it for the rest of the time of the year. So first off, when we're talking about significant figures, we're talking about digits in a number that actually have meaning. So a number can only be as accurate as the measurement tool that was used to find it. And also, if we're not dealing in a lab setting, if we're dealing with just solving problems on paper, an answer can only be as accurate as the numbers used in the problem. So, in order to be able to actually do problems, we first have to figure out what a significant digit is. So, significant digits. All non-zero numbers are significant. So if you have 1, 2, 3, 4, 5, 6, 7 in a problem, all those are going to be significant because it's a non-zero digit. So those are the easy ones. Now when we get to zeros, there's some rules that we have to follow. So we have the always rule, the never rule, and the sometimes rule. So the always rule is when a zero is sandwiched in between two non-zero digits. For instance, we have 7, 0, 1. Here, we know that our non-zero digits are significant, and here a zero is sandwiched between them, so that is always going to be significant. So the always is the sandwich 0. So here we have 3 sig figs. And that's how we're going to abbreviate sig figs. Next we have the never rule. The never rule is when we have zeros out in front of non-zero numbers. So zeros to the left. So these zeros are to the left of non-zero numbers. They do not count, so we only have 2 sig figs here. Now our sometimes rule. Our sometimes rule applies to when zeros are to the right of non-zero digits. So for instance, we can have 500, or we can have 500 with a decimal. If there is no decimal present in a number, the zeros to the right are not significant. So no decimal equals not significant. So here, we only have 1 sig fig. Because these 2 zeros do not count because we do not have a decimal place. Here, if we look at 500 with a decimal on it, these are going to count. So if a decimal is present, zero to the right is significant. So here we have 3 significant figures. Okay, so this is how we figure out our significant digits. Now we have to think about different operations if we're solving a problem. There are a few different rules that we have to learn about. One of them is for adding and subtracting, and the other one is for multiplication and division. When we are adding and subtracting, we will create an answer that has the same number as the least number of decimal places. Okay, so if we look at 14.3, we have 1 decimal place. If we look at 4.72, it has 2 decimal places. So our answer has to have 1 decimal place because that is the lowest number of decimal places we have. So go ahead and plug it into your calculator, 14.3 plus 4.72. And if you plug it into your calculator, you should get 19.02. But since we only are allowed to have only 1 decimal place, this is going to change to 19.0. The reason why this is becoming an O is because this 2 is less than 5. You guys know rounding rules. Anything less than 5 stays the same. 5 and up rounds the previous number up. So that is for adding and subtracting. Now for multiplication and division, instead of it being decimal places, we're talking about significant figures here. So we have to know our significant digits before we're able to do our multiplication and division. So multiplication and division. Here we have 2.71 times 9.1. I didn't throw any zeros in here. It'll be a little bit easier this time, but we will practice ones that have 0 on our worksheets. So here we have 3 sig figs. Here we have 2 sig figs. Our answer has to be to the least number of sig figs. So here we're going to plug this into our calculator, 2.71 times 9.1. We get 63.87 about. So right now I have 4 significant digits, but I need it to be only 2. So my 2 significant digits are going to be 6 and 3. But we have an 8 next to the 3, so 8 rounds up. So this is the correct answer that for this problem is going to be 64. Okay, so this is adding and subtracting. This is multiplication and division. Now sometimes we're going to have them in the same problem. We have to follow our order of operations. We do parentheses first and then multiplication. So here we're doing subtraction because that's what's in our parentheses. So for subtraction, we have to remember that we're looking at the least number of decimal places. So here I have 1 decimal place, here I have 2. So my answer should be to 1 decimal place. I'm doing 3.5 minus 1.89. I end up with 1.61. I'm only allowed 1 decimal place. So if I have 1.61, 1 is going to round 6 to be exactly the same. It's not going to round up. So for this part, we get 1.6. Now we need to multiply that by 4. Now I'm doing multiplication. I have to follow my multiplication rule. So that is the least number of significant digits. Here I have 2 sig figs. Here I have 1 sig fig. So my answer has to be to 1 significant figure. So I'm going to do 1.6 times 4, and that comes out to 6.4. Now this is 2 significant figures. I'm only allowed to have 1 because that's what my 4 tells me. 6.4 is going to round to 6. Lastly, when we are doing measurements. When we're doing measurements, we can only be as accurate as the measurement tool we are using. So here, if we're using a ruler, I set it up as centimeters, and you can notice that there's only markings at those centimeter lines. So if I have a piece of wood that I'm measuring, and it is right here, okay? Hopefully you can see these numbers, but if you can't, this is just a 2 and this is a 3. Now, I always have to add my my ones place because that is the marking that I have. So we know that's significant because our ruler tells us so. So we can look between the 2 and the 3 and realize it's not yet at the 3, so 2 is a definite number. Okay? Now, we know that it is a little bit more than 2, and it's a little bit less than 3. So we have to estimate what that digit is. Now, when I'm looking at it, I can see that it's a little bit more than 5. So I'm going to say it's about 2.7. Now, this 7 is an estimated digit because it is not clearly shown on my ruler that it is a 7. In each of your measurements, you're only allowed to have 1 estimated digit. I cannot say that this answer is 2.75 because I don't even have a 10th place mark there. Yes, 10th, whatever. I don't even have the 7 mark there, so how am I going to know that it's 7.5? That's not possible to know. So you have to just have your true digit and then your estimated digit.